NEC section 695.6 mandates protection for wiring from a generator that supplies a fire pump when the wiring is installed through any portion of a building. This requirement applies to all building types, regardless of occupancy or height. In a specific case such as a 12-story structure with sprinklers, considered a high-rise building according to NFPA 13, and where the generator is located in an attached parking garage, not part of the protected building, if the generator wiring is routed through the entire height of the building to the fire pump controller, then NEC section 695.6 would apply to the generator wiring routed through the building. This is because the wiring traverses a substantial part of the building from a generator not situated within the protected structure. The wiring needs protection as per NEC section 695.6, which encompasses firstly protection from fire and mechanical damage. The wiring must have adequate protection from fire, mechanical damage, and water throughout all phases of construction and occupancy. Secondly, separation from other wiring. The generator wiring must be separate from other wiring systems inside the building. Thirdly, fire resistance. The wiring needs to be installed to maintain its fire resistance rating for a minimum of 1 IR. Additional factors include ensuring that the generator wiring has suitable protection against physical damage during construction and future maintenance. The fire resistance rating of the wiring should undergo verification by proper testing or certification. The building code might contain supplementary requirements concerning generator wiring protection that must also be taken into account. When evaluating the installation of generator wiring for fire pumps, there are several crucial aspects to consider beyond the basic requirements outlined in NEC section 695.6. These considerations ensure a robust and reliable system that complies with all applicable codes and standards. Let's delve deeper into the specific requirements and best practices for achieving optimal protection. Firstly, understanding the scope of NEC section 695.6. This section primarily focuses on protecting the wiring that connects the generator to the fire pump controller when that wiring passes through any part of the building. The intent is to ensure that this critical wiring remains functional even during a fire, allowing the fire pump to operate and provide essential fire suppression capabilities. It's vital to recognize that this requirement is not limited to specific occupancy types or building heights. It applies universally to all buildings where a fire pump is supplied by a generator and the wiring traverses any portion of the building structure. Secondly, fire-rated cable and raceway systems. One of the most common methods for achieving the required fire resistance is to use fire-rated cable or raceway systems. Fire-rated cables are specifically designed and tested to maintain their integrity and functionality for a specified period, typically 1 or 2 hours, when exposed to fire. These cables are often constructed with specialized insulation and jacketing materials that resist burning and melting. Similarly, fire-rated raceway systems, such as conduits and cable trays, are designed to provide a protective enclosure for the wiring, preventing it from being directly exposed to fire. These systems are typically made from materials like steel or concrete and are designed to withstand high temperatures without collapsing or losing their structural integrity. When selecting fire-rated cables and raceway systems, it's crucial to ensure that they are listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or Intertek. This listing provides assurance that the products have been tested and meet the applicable fire resistance standards. Thirdly, physical protection from mechanical damage. In addition to fire resistance, NEC section 695.6 also requires that the wiring be protected from mechanical damage. This means that the wiring must be installed in a manner that prevents it from being cut, crushed, or otherwise damaged by physical forces. There are several ways to achieve this, including using rigid metal conduit, intermediate metal conduit, or other approved raceway systems. The choice of raceway system will depend on the specific installation conditions and the level of protection required. For example, in areas where the wiring is subject to heavy impact or abrasion, rigid metal conduit may be the best choice. In other areas, intermediate metal conduit or a cable tray system may be sufficient. It's important to ensure that all raceway systems are properly supported and secured to prevent them from being dislodged or damaged. Support should be spaced in accordance with the manufacturer's instructions and should be securely fastened to the building structure. Fourthly, separation from other wiring systems. NEC section 695.6 also requires that the generator wiring be separated from other wiring systems within the building. This is to prevent a fault in one wiring system from affecting the operation of the fire pump. There are several ways to achieve this separation, including running the generator wiring in a separate raceway system or using a physical barrier to separate it from other wiring. When running the generator wiring in a separate raceway system, it's important to maintain a clear separation between the raceway systems. This can be achieved by using separate supports or by maintaining a minimum distance between the raceways. If a physical barrier is used to separate the generator wiring from other wiring, it must be made of a fire-resistant material and must extend the full length of the wiring. The barrier should also be securely fastened to the building structure to prevent it from being dislodged. Fifthly, protection against water damage. Water damage can also compromise the integrity and functionality of generator wiring. Therefore, it's essential to take steps to protect the wiring from water exposure. This can be achieved by using waterproof or watertight raceway systems and fittings. In areas where the wiring is exposed to the weather, such as outdoor installations, it's important to use raceway systems and fittings that are specifically designed for outdoor use. These products are typically made from corrosion-resistant materials and are designed to prevent water from entering the raceway system. It's also important to ensure that all splices and terminations are properly sealed to prevent water from entering the wiring. This can be achieved by using waterproof connectors or by applying a sealant to the splices and terminations. Sixthly, fire stopping. When generator wiring penetrates fire-rated walls or floors, it's essential to install fire-stopping materials to maintain the integrity of the fire-rated assembly. Fire-stopping materials are designed to prevent the spread of fire and smoke through openings in fire-rated walls and floors. These materials typically consist of a combination of mineral wool, intumescent materials, and sealants. Mineral wool provides a thermal barrier that prevents heat from transferring through the opening, while intumescent materials expand when exposed to heat, sealing the opening and preventing the passage of smoke and flames. Sealants are used to fill any remaining gaps and to provide a watertight seal. When selecting fire-stopping materials, it's important to ensure that they are listed and labeled by a recognized testing laboratory and that they are installed in accordance with the manufacturer's instructions. The fire-stopping system should be designed to provide the same fire resistance rating as the wall or floor that it is penetrating. Seventhly, coordination with other trades. Installing generator wiring for fire pumps often requires coordination with other trades such as mechanical contractors, plumbers, and sprinkler fitters. It's important to communicate with these trades to ensure that the wiring is installed in a manner that does not interfere with their work and that all applicable codes and standards are met. For example, the generator wiring should not be installed in a location where it will obstruct access to mechanical equipment or interfere with the operation of sprinkler systems. It's also important to ensure that the wiring is properly supported and secured so that it does not create a hazard for other trades. Regular meetings and communication can help to identify potential conflicts and to develop solutions that meet the needs of all trades. Eighthly, documentation and record keeping. Accurate documentation and record keeping are essential for ensuring that the generator wiring installation is properly maintained and that it complies with all applicable codes and standards. This documentation should include detailed drawings, specifications, and test reports. The drawings should show the location of all generator wiring, raceway systems, and fire-stopping materials. The specifications should describe the materials used and the installation methods employed. The test report should document the results of any fire resistance testing or other performance testing. All documentation should be kept in a safe and accessible location and should be readily available for inspection by building officials or other authorities. Ninthly, periodic inspection and maintenance. Periodic inspection and maintenance are essential for ensuring that the generator wiring installation remains in good condition and that it continues to provide the required level of protection. The frequency of inspections will depend on the specific installation conditions and the applicable codes and standards. However, a good rule of thumb is to inspect the wiring at least once a year. During the inspection, the wiring should be visually inspected for any signs of damage, such as cuts, abrasions, or corrosion. The raceway systems should be inspected for any signs of damage or deterioration. The fire-stopping materials should be inspected to ensure that they are still in good condition and that they have not been disturbed. Any deficiencies should be corrected promptly to prevent further damage or to maintain the required level of protection. 10th, compliance with local codes and regulations. In addition to the requirements of NEC section 695.6, it's also important to comply with all applicable local codes and regulations. These codes and regulations may impose additional requirements for generator wiring installations, such as specific requirements for fire resistance, separation, or physical protection. It's important to consult with local building officials or other authorities to ensure that the installation complies with all applicable requirements. Failure to comply with local codes and regulations can result in fines, penalties, or even the shutdown of the building. By carefully considering these aspects and adhering to the relevant codes and standards, one can ensure that the generator wiring installation for fire pumps is robust, reliable, and compliant, providing essential fire protection capabilities for the building. When dealing with fire pump installations and generator wiring, it is crucial to understand the intricacies of the National Electrical Code, specifically NEC section 695. This section outlines the requirements for the installation of fire pumps, including the power source, wiring, and control equipment. A thorough understanding of NEC 695 is essential for ensuring the reliable operation of the fire pump system, which is critical for life safety in the event of a fire. Firstly, NEC 695.3 covers the power source requirements for fire pumps. It mandates that the power source must be reliable and capable of supplying the necessary power to the fire pump under all operating conditions. The code recognizes several acceptable power sources, including a dedicated utility service, an on-site generator, or a combination of both. When a generator is used as the power source, it must be sized to adequately handle the fire pump's load, as well as any other essential loads that may be connected to the generator. The generator must also have a reliable starting system and be equipped with automatic transfer switches to ensure a seamless transition to generator power in the event of a utility outage. Secondly, NEC 695.6 focuses on the wiring requirements for fire pumps. This section outlines the specific requirements for the wiring that connects the power source to the fire pump controller and the fire pump motor. The wiring must be sized to carry the full load current of the fire pump motor with appropriate overcurrent protection. The wiring must also be protected from physical damage and fire, as discussed earlier in this narration. In addition to the general wiring requirements, NEC 695.6 also includes specific requirements for the routing of fire pump wiring. The code mandates that the wiring must be routed outside of the building, or if it must pass through the building, it must be enclosed in a fire-rated enclosure or raceway system. This is to ensure that the wiring remains functional even in the event of a fire, allowing the fire pump to continue operating. Thirdly, NEC 695.12 addresses the overcurrent protection requirements for fire pumps. This section outlines the specific requirements for the overcurrent protective devices that are used to protect the fire pump motor and the associated wiring. The overcurrent protective devices must be sized to allow the fire pump motor to start and run under all operating conditions without tripping or interrupting the power supply. The code also specifies the types of overcurrent protective devices that are permitted to be used for fire pump applications. Fourthly, NEC 695.14 covers the control circuit requirements for fire pumps. This section outlines the specific requirements for the control circuits that are used to start, stop, and monitor the fire pump. The control circuits must be designed to be reliable and fail-safe, ensuring that the fire pump will start automatically in the event of a fire. The control circuits must also be protected from physical damage and fire, and they must be separated from other wiring systems within the building. Fifthly, NEC 695.15 addresses the pump room requirements for fire pumps. This section outlines the specific requirements for the location and construction of the room or area that houses the fire pump. The pump room must be located in a safe and accessible location, and it must be protected from fire, flood, and other hazards. The pump room must also be adequately ventilated and illuminated to ensure the proper operation of the fire pump equipment. Sixthly, NEC 695.16 covers the emergency power systems for fire pumps. This section outlines the specific requirements for the emergency power systems that are used to supply power to the fire pump in the event of a utility outage. The emergency power system must be capable of providing power to the fire pump for a specified period, typically 2 hours, and it must be equipped with automatic transfer switches to ensure a seamless transition to emergency power. Seventhly, NEC 695.18 addresses the testing and maintenance requirements for fire pumps. This section outlines the specific requirements for the testing and maintenance of fire pumps to ensure that they are in proper operating condition. Fire pumps must be tested periodically, typically on a weekly or monthly basis, to verify that they start and run properly. The fire pump system must also be inspected and maintained regularly to ensure that all components are in good working order. In addition to the requirements of NEC 695, there are also several other codes and standards that may apply to fire pump installations. These include an FBA 20 standard for the installation of stationary fire pumps for fire protection, which provides detailed requirements for the design, installation, and testing of fire pump systems. It also includes the International Building Code, IBC, which includes requirements for fire protection systems in buildings, including fire pumps. It is crucial to consult with local building officials and fire marshals to ensure that the fire pump installation complies with all applicable codes and standards. When installing a fire pump, it is essential to use qualified and experienced contractors who are familiar with the requirements of NEC 695 and other applicable codes and standards. A properly installed and maintained fire pump is a critical component of a building's fire protection system, and it can save lives and property in the event of a fire. Understanding and adhering to the requirements of NEC 695 is essential for ensuring the reliable operation of the fire pump system and for protecting the safety of building occupants. When examining the nuances of fire pump installations, one must also consider the importance of coordination with other building systems. The fire pump system does not operate in isolation. It interacts with various other systems within the building, and these interactions must be carefully managed to ensure the overall effectiveness of the fire protection strategy. Firstly, integration with the fire alarm system. The fire pump system should be integrated with the building's fire alarm system to provide a coordinated response to a fire event. When the fire alarm system detects a fire, it should automatically signal the fire pump to start. This ensures that the fire pump is immediately available to supply water to the sprinkler system or fire hose connections. The integration between the fire alarm system and the fire pump system should be carefully designed and tested to ensure that it functions reliably under all conditions. Secondly, interaction with the sprinkler system. Fire pump is primarily responsible for supplying water to the building's sprinkler system. The sprinkler system is designed to automatically detect and suppress fires by discharging water onto the fire area. The fire pump must be sized to provide adequate water flow and pressure to the sprinkler system to ensure that it can effectively control the fire. The interaction between the fire pump and the sprinkler system should be carefully coordinated to ensure that the system operates as intended. Thirdly, coordination with the standpipe system. In addition to the sprinkler system, the fire pump may also supply water to the building standpipe system. The standpipe system consists of a network of pipes and fire hose connections that are located throughout the building. Firefighters can use the standpipe system to connect fire hoses and manually suppress fires. The fire pump must be sized to provide adequate water flow and pressure to the standpipe system to ensure that firefighters can effectively combat the fire. Fourthly, interface with the emergency generator system. As discussed earlier, the fire pump is often powered by an emergency generator system to ensure that it can operate even in the event of a utility power outage. The emergency generator system must be sized to adequately handle the fire pump's load, as well as any other essential loads that may be connected to the generator. The transfer switches that connect the fire pump to the generator must be carefully designed and maintained to ensure a seamless transition to generator power in the event of a power outage. Fifthly, collaboration with the building management system (BMS). The fire pump system can be integrated with the building's building management system (BMS) to provide remote monitoring and control capabilities. The BMS can be used to monitor the status of the fire pump, including its operating pressure, flow rate, and power supply. The BMS can also be used to remotely start and stop the fire pump and to adjust its operating parameters. The integration between the fire pump system and the BMS can provide valuable information for building operators and can help to improve the overall efficiency and reliability of the fire protection system. Sixthly, alignment with HVAC systems. The fire pump room should be adequately ventilated to prevent overheating of the fire pump motor. The HVAC system should be designed to provide adequate airflow to the fire pump room even during a fire event. The HVAC system should also be equipped with smoke detectors to shut down the system in the event of a fire. This will prevent the HVAC system from spreading smoke and fire throughout the building. Seventhly, integration with plumbing systems. The fire pump system must be connected to the building's water supply system. The water supply system must be capable of providing adequate water flow and pressure to the fire pump to ensure that it can operate effectively. The connection between the fire pump and the water supply system should be carefully designed to prevent backflow and contamination of the water supply. Eighthly, adherence to architectural considerations. The fire pump room should be designed to be aesthetically pleasing and to blend in with the overall architecture of the building. The fire pump room should also be located in a location that is easily accessible for maintenance and inspection. The architectural design of the fire pump room should take into account the functional requirements of the fire pump system as well as the aesthetic considerations of the building. Ninthly, electrical system integration. The electrical system that supplies power to the fire pump must be designed to be reliable and fault-tolerant. The electrical system should be equipped with surge protection devices to protect the fire pump motor from damage due to electrical surges. The electrical system should also be designed to provide adequate grounding to prevent electrical shock hazards. Tenthly, structural integrity and seismic design. The fire pump room should be designed to withstand the forces of gravity, wind, and earthquakes. The structural design of the fire pump room should be in accordance with all applicable building codes and standards. Fire pump equipment should be securely anchored to the building structure to prevent it from being damaged or displaced during a seismic event. By carefully coordinating the fire pump system with these other building systems, building owners and designers can ensure that the fire protection system operates effectively and protects the safety of building occupants.